Capacitors store charge by maintaining a potential difference. The most important equation for capacitors that applies to all capacitors is Q equals C times change in V. The amount of charge stored in the capacitor is equal to the capacitance, which is measured in farads, times the potential difference across the capacitor. In this class, we care most about two types of capacitors. The first is a parallel plate capacitor, which has two plates separated by a small distance. Its capacitance is calculated by this equation. It depends on the cross-sectional area of the plates and the distance that separates it. The second type is a spherical capacitor, which is just a sphere holding charge. Its capacitance is calculated by this equation, where r is just the radius of the sphere. Often, we'll ask you about energy stored in a capacitor. Because Q equals C times change in V, we can actually derive three equations for the energy of a capacitor. Now, we may ask you to compare energy storage and capacitors in different circuits, how capacitance, charge, and potential change as we change the circuit physically, or a combination of the two.